There's this one fundamental idea about how AI models like GPT-4 understand language. And what if I told you it might just be wrong? Or, at least not the whole story. Today, we are digging into a forgotten secret about transformers. And honestly, it kind of changes everything you thought you knew about how they read. So let's get into it. Okay, so to really get the secret, we have to start with the puzzle itself. At their very core, the powerful attention mechanisms inside a transformer are, well, they're kind of dumb in one specific way. They see a sentence not as an ordered line of words, but more like a jumbled up bag of words. So how in the world do they get anything right? And that really is the central question, isn't it? If the model can't tell the difference between dog bites man and man bites dog just by looking at the words themselves, how does it ever make sense of a story or a command or anything? This was the core challenge that AI engineers had to solve right from the beginning. Now, there's a technical term for this problem: permutation invariance. Basically, the self-attention part of a transformer is absolutely brilliant at seeing which words are related to each other, but it's naturally blind to their order. It just sees a set of items, and as you know, the order you list things in a set doesn't change the set itself. For years, the solution to this seemed super obvious. I mean, it's logical, right? If the model is lost and doesn't know the order of things, you just give it a map. The thinking was you had to explicitly tell it where each and every word belongs in the sentence. And that map has a name: positional encodings. You can think of them like little GPS coordinates that get attached to each word's data, telling the model, hey, this is the first word, this is the second, this one's the third, and so on. For a long time, this was considered a fundamental, non-negotiable requirement. But it turns out that map might have been unnecessary this whole time. And that brings us to the heart of our story. A fascinating paper argues that the need for these positional maps might just be one of the biggest misconceptions in modern AI. And the craziest part? The truth has been hiding in plain sight for years. So here it is, the core claim, right from the paper itself. It says that by stacking these individually order-blind processors on top of each other, the whole system suddenly becomes sensitive to the sequence. No map needed. There's just one catch. The model needs to have more than one layer. Now, what's so crucial here is that the authors don't even call this a new discovery. They call it a petroglyph, like an ancient carving on a rock wall. It's a truth that was actually discovered way back in 2019, around the time of GPT-2, but it was somehow lost or just overlooked in the absolute explosion of the large language model era. But how does this actually work, right? How can you stack a bunch of things that are individually blind to order and suddenly have them gain sight? Well, the magic isn't in any single part. It's all about how they work together, layer by layer. See, the key to understanding this is that each layer doesn't just see the original words, it sees what the layer below it saw. And this creates this incredible cascading effect, building up a totally unique history at every single position in the sentence. Okay, let's look at this diagram. On the left, you've got the sequence ABC. In that first layer, the model is just seeing a growing set of the words it's processed so far. Simple enough. But the real magic happens at the second layer. When it gets to position C, the model doesn't just see the set ABC. No, it sees the entire history of sets that were created by the layer below it. This unique historical record is everything. Now watch what happens on the right when we just swap the first two words to BAC. The first layer still just builds simple sets, but because the sequence started with B instead of A, the history that the second layer sees is different from the absolute beginning. And that initial difference just cascades all the way up through the model. So here is the crucial point. By the time the model gets to the end of the sentence, the final context it sees is completely different for the two sequences. The first one's history contains the set A, but the second one's contains B. Because these historical fingerprints are unique, the model can tell the two sequences apart. It learns the order implicitly, no map required. But, and this is a really important but, there's a critical piece of nuance here. This magical property has a weakness. It doesn't work if you only have one layer. And this exception is actually what makes the whole explanation so believable. So to put it simply, with multiple layers, any tiny difference at the start creates a ripple effect, changing all the future outputs. The model becomes what the paper calls fully position sensitive. But a single layer model, it just doesn't build up that rich history. So for the very last word in a sentence, it'll spit out the same result no matter what order the words before it were in. It needs that second layer to see the difference.
So you see, this isn't just a technical deep dive. It's a detective story. It's about a kind of scientific amnesia. The fact that multilayer transformers don't need positional encodings isn't some new discovery. It's a foundational truth that was just forgotten.
This timeline really shows you how it happened. The original finding comes out in 2019, right before the massive LLM boom. Then, in the absolute chaos and speed of the next few years, this knowledge gets buried, only to be rediscovered in 2022 and treated like some brand new insight. I mean, the question is, how does something so fundamental just get lost? Well, the paper provides some really compelling evidence of the scientific amnesia in action, just by looking at what other major AI papers were citing. For instance, check this out. The paper for Code Llama, a huge model from 2023, calls this finding recent work, and it cites papers from 2022 completely missing the original 2019 source. And it wasn't a fluke. It happened again, with DeepMind's Flamingo model in 2022. It's just more proof of how quickly a new, incorrect history can form when a field is moving at the speed of light. And look, this is so much more than just a quirky fact about AI. It's a whole case study in meta-science. It's about the sociology of research, about how we cite our sources, and the very real risk of building these massive skyscrapers of knowledge on foundations that we don't even remember or fully understand anymore. And that leaves us with a really fascinating and, yes, slightly unsettling question. As AI continues to accelerate at this unbelievable pace, what other petroglyphs, what other fundamental forgotten truths are lying just beneath the surface, waiting for someone to rediscover them?